Hey everyone, it's Alice here from Top Mark Science, and today we will be looking at atoms and reactivity. You might find it useful for this video to have a periodic table to hand. In this video, we will be exploring group names on the periodic table, properties of groups on the periodic table, and the link between electron arrangement and reactivity. Let's get started. In my previous videos, we have looked at the basic structure of the atom and how they become ions, so that atoms can establish full outer shells. Remember, a full atom is a happy atom. So where have these electrons come from? Simple answer, another atom, which is the basis of a chemical reaction. Atoms on the periodic table can react with each other, and how vigorously they react depends on their place on the periodic table and place within their groups. They all have names. For example, group 1 are the alkali metals, apart from hydrogen, which is a non-metal, but it still has one valence electron, which is why it's seen floating above the table in some places. The alkaline earth metals of group 2, the transition metals in between. Group 7 are also known as the halogens, and group 0, the noble gases. The alkali metals of group 1 are reactive elements. They react well with water. When they react with water, they form a metal hydroxide and hydrogen gas is released. This can be seen as fizzing, and the water turning a blue-purple colour when universal indicator is added, indicating an alkali solution has formed. As you go down the group, when adding these metals to water, their reactions appear to get more reactive. So how is this happening? Look at the size of the atoms. As you go down the group, the atoms get larger. We get more shells, which provide a shielding effect between the positive nucleus and negative electrons. As the atoms get larger though, the distance between the nucleus and valence electron also gets further. In other words, the distance between a positive nucleus and negative electron gets further. So initially, there is a strong attraction in smaller atoms. This is called electrostatic attraction. As the atoms get larger, the valence electron gets further away, and this attraction weakens, making it easier for the larger atoms to lose this outer electron, and so become more reactive than the smaller atoms, which hold on to their outer electrons much more tightly. By losing this single outer electron, it reacts and it becomes stable. They can all react, just with different levels of vigour. Pause the video here for our first checkpoint and have a go at the activities on the screen. If you finish, have a go at the challenge. Let's go through some answers. Have your marking pens at the ready. So remember, group 1 are the alkali metals. Group 2 are alkaline earth metals. Group 7, the halogens, and Group 0, the noble gases. From least to most reactive, we have lithium, the smallest atom up to potassium, the larger of the three. And the challenge. First of all, Group 1 atoms are reactive because they only have one electron to lose in their outer shell. As you go down the group, they get more reactive. Because of the distance of outer electrons get further from the nucleus, and therefore electrostatic attraction weakens, and so it's easier to lose the outer electron in order to be stable with a full outer shell. Well done everyone, let's move on. Let's look at group 7, the halogens. So earlier in the video, I mentioned that atoms can react due to the gain and loss of electrons to get full outer shells. So if this lithium reacted with this fluorine atom, lithium would lose one outer electron and give it to fluorine. So they both have full shells. So what happens to group 7 reactivity then during these reactions? It's simple really. It's the opposite to group 1. As you go down the group 7 elements get less reactive under the same principles as what we looked at earlier. A positive proton in the nucleus has orbiting negative electrons in shells which increase with distance as the atoms get larger going down the group. So the electrostatic attraction weakens, meaning those at the top of the group find it easier to gain electrons because of the strong attraction. And those at the bottom with weaker attraction find it harder to gain electrons to have full outer shells. So they are more reactive at the top, less reactive at the bottom. Pause the video here and try this activity. Fill in the gaps of the sentences using the words in the box. If you finish, try the challenge. Let's go through the answers. You can explain trends in reactivity as you go down a group. As you go down a group, atoms get larger. As atoms get larger, they have more electron shells. As atoms get larger, the distance between the nucleus and outer electrons increase. This reduces the force of electrostatic attraction, so it becomes easier for the atoms at the bottom of group 1 to lose the single outer electron, and easier for atoms at the top of group 7 to gain a single electron to have full outer shells. Tick your answers if you got them correct, or annotate if not so you know for next time. Now on to the challenge answers. The challenge was to predict the reactivity of group 2 elements and noble gases. Will group 2 follow the same pattern as group 1? Because they only have 2 electrons to lose, and it's easy to do this. As you go down the group, the atoms get larger, so electrostatic attraction gets weaker. Therefore, it becomes easier to lose those electrons, and so they become more reactive. Noble gases, group 0 on the other hand, already have full shells, so they cannot gain or lose electrons, so they are unreactive. Pause the video here and try this task. Use the list of statements to fill in the boxes to explain the reactivity of group 1 and 7 elements. If you finish, try the challenge. Let's have a look at how we got on. So at the top of group 1, atoms are smallest. So electrons are less easily lost and are therefore less reactive. But at the bottom of the group, electrons are more easily lost and so are more reactive, and vice versa for group 7. You can pause the video here if you want more time to check and annotate your answers. If you did the challenge, beryllium is the least reactive, the smallest of the atoms. Calcium is more, and barium is the most, being the largest of these atoms. Time for our end of video quiz. Ready to see what we've learnt? Question 1. What name is missing? Transition metals, noble gases, alkali and alkaline earth metals? The halogens were missing, aka group 7. Question 2. Elements at the bottom of group 1 are more or less reactive? They are more reactive. Question 3. Why are atoms at the top of group 7 more reactive? Is it easier to gain electrons or easier to lose electrons? It's easier to gain electrons. Question 4. What attraction keeps electrons close to the nucleus? Electrostatic. And final question, which group are unreactive and why? The noble gases of group 0, because they already have full outer shells. Pause the video here and review your progress. Be honest with yourself, it's a useful tool to know your strengths and areas for development. Thank you so much for watching this video, guys. If you enjoyed it and would like to see more from Top Mark Science, you can like this video and subscribe to this channel. I'll see you next time.